back to the channel. So today we've got this 05 Dodge Dakota, and it's got an AC concern, I guess. He's taken it to a couple places. It's been charged up. It was at Jiffy Lube, so I don't know how well they got it. We got a pressure sensor code, so I don't know. So yeah, we got a P0533, and it's the AC pressure sensor circuit high, and that's pretty much all I got right now for you. But so yeah, I just wanted to see if there was any code stored, and there is. I guess he's replaced that sensor already. The one of the pressure sensors. I don't know if there's more than one on here. Some systems have a low pressure and a high pressure sensor, so I'm gonna go look at some diagrams and just go kind of get a visual inspection under the hood, and then just go from there. So let's get started. I'm in Identifix right now. I've just typed in the code to see what it says. Some of the other people are saying that they replaced the sensor. So I mean, the sensor's already been replaced apparently. And this is just telling us to compare the actual high slide pressure, so to get the gauges on there, and then compare it with like the reading we're getting on the scan tool, and then it's just letting you know like what the wires are. The orange wire is the 5-volt power supply, and then we got the black light blue ground, and the dark blue is the signal wire. So that's going to be the signal going back to the ECM, I believe, and that's probably the wire that we're going to be looking at. So then it says to jump the blue wire to the black light blue wire while monitoring scan data of the AC pressure transducer. So the voltage should go from near 5 to 0 volts. So yeah, that's that. So here, let's go find some diagrams. I like the OEM diagrams. Air conditioning wire diagram, first one. So I guess we'll look at that one. So, and I guess, I mean, the TIPM is involved here. That's never good. They are known to be bad. All right, I don't think that's what we need. Looking for the pressure sensor. I had a super basic diagram earlier, but yeah. It's like it's not what we need either. Okay. Emission control. Okay, there we go. So yeah, so this is what we need right here. That's our pressure transducer right there. We got the signal, the 5-volt supply, and the sensor return is just going to be the ground. So, and that, you can see that is, it goes back to the TIPM. So this is the diagram I was talking about that I had pulled up just a second ago. And so, I mean, I don't think we, yeah, I don't think we have, I don't think the compressor or anything like that is an issue here, or the charge. I mean, I haven't even tested, to see what the pressures are yet, and we'll do that in a second. But I mean, it's been to 2 other shops, and I assume that they charged it up. Probably the first thing they did, or replace that sensor. So I think the next step here, let's just go visual inspection and just go from there. Okay, so I just take a quick look, and there is our sensor, our pressure sensor in question, and it is brand new. Compressor looks old, but I'm not really worried about the clutch or the compressor itself. We have a DTC for a circuit high, so you know, it's going to be somewhere in the signal circuit, and this does appear to be the only pressure sensor, so they probably replaced the right one. However, kind of wish I had the old one. This one looks super cheap. I don't know, it looks like the China white box special, but I don't know, I guess it's kind of hard to tell. So I just got the PIDs for that module pulled up, and so here we got the AC pressure voltage, AC pressure, the actual pressure in PSI, and it's showing, I don't know if you guys can see that, it's 101 PSI, and we're showing 1 volt on the circuit there, so I'm pretty sure that's the only PIDs that we're gonna need right now. So I'm just gonna select those two and make it easier to see. So, all right. So I want to first check. I'm gonna ground this lead from my meter over here on the battery, and then I want to see the actual readings at the sensor real quick. I don't know if you guys can see that. Okay, I think you guys can see that. So these wires are, the color coding is wrong. That's the wrong notes anyways, but I wrote down what it was saying on the orange, but it's a yellow orange. So anyways, it doesn't matter. So I got my my lead, like I was saying, on the ground for on the battery, and so I'm gonna check this that 5 volt wire first. Hold on now. Make sure the key's on. Well, that's a bad ground. Yeah, you know what? This terminal is super dirty. Always get a good ground. This is a perfect example. When you're testing something, make sure you got a good ground, you know. So you just saw firsthand what happens when you have bad ground. Look, this is just crusted in crap. It's even, okay. Let's try that. Okay. There we go. Okay, so 4.97 volts, 5 volts. So that's our 5 volt reference. Now, here. So that's going to be our signal wire. It says 1.02 volts, and up here on the data PIDs, I don't know if you can see that or not. So you can see up here it matches what the computer's seeing. So now we need to check that ground. So I'm just going to move this this lead over to the positive. Make sure I got a good connection there. And then I'm just going to go to this ground wire, that other wire. This is a 3-wire sensor, so it's always going to be a power, ground, and signal. So you're seeing 13 volts right there because I have the battery charger on it. I just wanted to make sure that the battery didn't go dead while testing. It's always a good idea. You have a low battery, you're going to get skewed readings, if you can get them at all. So, you know, a lot of cars, they won't even, you know, the computers won't even communicate or operate properly with 11 volts or 10 volts, or, you know, they've got to have the proper, you know, the specified amount of voltage that they're designed to run on to run. So, okay, so good ground, good power, and our signal seems to be exactly what the computer is seeing. So what's the issue here? Also, you know, for circuit integrity, so I'm gonna unplug that sensor, and I believe that pressure voltage right there, that should go to 5 volts. So make sure you guys can see that. Nope, you cannot. So I'm gonna unplug it and then I'll bring it over to you. Okay, 5 volts. So, you know, this is kind of indicating that the circuit is good. So let's just continue on. We gotta find the issue. Now you can see the low side is right at 100 and the high side is, I mean, it's more like 120, but I don't know. I think there might be something wrong with my gauge. I don't know. Those two pressures should be equal. Like, they should both be at 100. The system should equalize overnight. You know, I haven't started this car yet, so I'm gonna go start it up right now, and then we're gonna see what the pressures are and compare it to the scan tool. Okay, let me go turn the compressor on. I got the AC on, and this compressor is not turning on. So maybe we do have a compressor issue. Oh, also, nothing is changing on this live data here, so I'm gonna whack that the compressor clutch and see if it engages. Okay, so just watch those gauges. That fan is like super close to that clutch, so this is sketchy at best. Nothing. All right, I'm gonna go turn it back on, and I'm gonna see if we're getting power to that compressor clutch, and then go from there. I just got the power probe out here. You could use your multimeter to check this voltage as well. I just want to see, you know, if we're getting power through this connector to that clutch. And like I said, that fan is super close. So, and I don't know which wire is which. I'm gonna poke them both. Okay, we got 14 volts at that wire. and we got ground at that wire. So that clutch is not turning on. We got power, we got ground, which means there's power coming from the control switch through the harness, wherever it needs to go to the compressor clutch. And the clutch is not turning on. So I'm gonna do one more thing and then I'm gonna call it a compressor. And I'll talk a little bit more about that call in a minute after I check this. All right, so I'm going to show you guys just a couple different methods of checking this clutch. So this harness here goes to that clutch on the compressor, and when it gets the power and ground it needs from the harness here, which it has, you know, you press the button in there, sends power to the clutch, engages it. So I'm going to show you how to test that compressor clutch a couple different ways. I'm going to use my power probe to actually put power to it and see if it works, and you'll be able to tell if there's a resistance through it with the power probe. But I'm also going to show you on a meter, just so you guys can see how to, you know, test a solenoid or anything with coil windings. So, all right, I got the ground wire there, back probe, and don't worry, all of you watching this thinking, oh, don't fry a computer. Well, if you're thinking that, then you're not paying attention, because this is not connected to anything. It's just the clutch. So this is just going to that clutch. All right, so when I probe this, we should show something on that power probe to let us know that there's you know, a complete circuit here, and there's not. So I mean, there's no, you know, and this is kind of redundant because there was already power being applied to it, but I'm trying to show you how to test this clutch if you need to. So got the power and ground and nothing. Applying power, I don't know if you can see that. Nothing. There's nothing there. So and you can do the same thing up here on the pins. You know, I could touch those and that, and there should be continuity, and there is actually. You see, I don't know if you can see that. I'm gonna get the meter out to show you guys this. So there is, well, I think I need the meter anyways. I don't trust that power probe for, you know, checking resistance. I just don't. So, okay. So, I don't know if you guys can see that, hopefully. Nope. All right. Oh, there. Yep, you guys can see that. Oh well. So then what's gonna happen when I put these together? All of a sudden we got continuity. So this is how you check your leads as well. I gotta flip it on there. Okay, there we go. So we got like 0.5 ohms of resistance through these leads. I'm okay with that. Well, actually this lead was pulled out, so let me see here. Okay, 0.3, so always check your leads. Perfect example. Okay, so don't like that. Don't want to bend the pins. I'm going to use the different. Oh, not compatible. Okay. A little adapter for that. So I'm just going to grab this again, and I'm going to take a resistance measurement. These are not the right probes here. So we were getting like 1.4 mega ohms. That's a lot. That's a bad clutch there. Another perfect example of don't trust the power probe for that. Let's see here. To back probe it. Yep. What I'm concerned about here is this connector. I'm gonna grab some different leads real quick. All right, that'll be easier. I mean, I got this. This one fits in there really good, and it's like a little alligator clip like that, and they just fit right on those little prongs pretty good, and they don't like stress anything. So let's see here, it's just easier with, you know, I only got two hands here, so this clutch is shot. The only other thing, I might pierce these wires real quick just to make sure that it's not a connector issue, and then I'm gonna call it a compressor. Unless you can buy the clutch separately, then I don't know, I'll take the belt off and see how well it spins and what it feels like, but usually I just replace the whole compressor, because I mean, you can see all this residue on here. Now that's from it leaking right up here on that main bearing there. They got a seal, and this thing needs a compressor. I mean, I'm confident if this had a compressor, it would run, it would work. But let me just pierce those wires real quick. Okay, like I said, you know, this is mainly for demonstration purposes. Well, I mean, you should do this. You should check the wiring. But I mean, this is gonna be a bad clutch, you guys. I am not a fan of these piercing probes, but they're the ones that I found first, so yeah. So see that? Same reading. I just pierced the wires. It's not the connector. You got the same resistance through the whole clutch circuit. So I do, that's it. We got a bad compressor, guys. The computer is seeing the right pressure, the right voltage. So yeah, I don't know what to say about that code. It could have been caused from them unplugging it. And they, I don't know. So. All right, so I did want to show you guys something else though. This is just a compressor I had laying about the shop. It is a bad compressor. The inside of the compressor is bad, but the clutch is good. So I wanted to show you, you know, what should happen when there's power applied to a compressor clutch. And so I got the ground for this power probe on the ground, and then I have my meter lead over there. Let's see here, I think. There we go, see? Now, watch the clutch. I don't know if the camera can see that. See it? It engages. You know, this free spins, the clutch engages, and it causes the compressor to actually start pumping. So there you have it. Okay, so that's about it. Yeah, you know, as far as that pressure circuit code, I don't know. This was at, you know, at least 2 other shops, including, you know, the local Jiffy Lube, and they were messing around with it. I don't know, maybe they were messing with things, maybe, you know, maybe that module saw high voltage and it just stored this code, or I don't know. But you know, we tested the circuit. The circuit seems to be operating fine. You know, we tested the clutch, and that's the key point that I want you guys to take from this video is don't go down these rabbit holes. Yeah, there's a pressure code, which very well could disable the clutch, but we were getting 12 volts at that clutch, and it's not operating. So if it's not operating, the compressor is not working. You know, like I was saying, that clutch engages, and it causes that pulley to now spin the compressor, which creates the pressure, you know, on the high side. And I wasn't doing that, you know. Even when we unplugged it, manually applied power, that's an excellent way to test any solenoid. 12 volt solenoid, make sure you look at your circuits and know your circuits, but a compressor clutch is most likely always going to be a 12 volt circuit, a power or ground. You know, you press the switch and it goes through whatever type of circuitry that car has. And it probably goes through the tip-em and then to the compressor clutch. So there's power there. You know, the switch is lighting up. You know, it's turning off, turning on. And I mean, but all that's irrelevant. The point is that, you know, we tested and we found the issue. If there happens to be another issue with that pressure circuit, then, you know, we'll figure that out later. But I can pretty much guarantee you that when I put a compressor in this, that it's gonna run. I do guarantee you. And that's precisely why I showed, you know, I got the old compressor laying about in the shop, and I showed you what a good one looks like. And I looked at that footage, and you can't really see it moving. Maybe I'll zoom in a little bit. So if I do that, then you'll already have seen that by now. But yeah, so I don't know why I decided to film this one, but I did, and I'm glad I did, because it ended up being, you know, not what it seemed. So that's why you test, you know, test everything and then replace. Don't just, you know, flip the switch and, you know, see the code and then, well, it must be a bad new sensor. You know, hitting the switch and, oh, it must be the tip-em, or, you know, test the actual component. And in this case, it's the compressor. And the reason why we know that is because, well, for one, the clutch wasn't engaging, but for two, when we looked at the pressures, like on our gauges, not the scan tool, on the gauges, there was no action. It was not, nothing happened. So, you know, if you're ever looking at your gauges and nothing's happening, go look at that compressor. Make sure that it's operating properly. So anyways, I was trying to make a short, quick video, and this is ending up to be way longer than I anticipated, but I hope you guys enjoyed this one. And as always, you know, like, subscribe. It helps my channel grow, and I appreciate you guys when you do that. So anyways, have a good one. I'll see you next time. So I just wanted to pause real quick and explain something. This is the next day, but I'm going to put it in this video. First off, the client decided to replace the compressor themselves. So they're going to have Jiffy Lube evacuate it for them, and then either him or Jiffy Lube's going to replace this sensor, or I mean this compressor, and then I doubt it'll be back, honestly. But I just wanted to mention that circuit high code, yes, it could very well be caused by unplugging the sensor, or, you know, messing around with the circuit. But, you know, there's also a possibility that, you know, while they were trying to fix that issue, they replaced the compressor with a bad eBay compressor from some junkyard, and then created another issue. So there very well could still be a circuit issue once that compressor is operational. And I informed the client of this. You know, I told them I don't recommend having Jiffy Lube do this. But what can you do? Yeah, I quoted him for the compressor, and he wants to return it to eBay and then buy one himself from O'Reilly's. He knows somebody that's going to give him a discount. So, you know, You can't win them all. But I just wanted to clarify that so you guys understood that, you know, there's a possibility that that compressor won't fix this issue. When you have a circuit code not pertaining to the compressor, then that indicates there's another issue. So, you know, unfortunately we couldn't get far enough to get to the bottom of it 100%, but, you know, found a bad compressor, so it was still a good video.